battery charger out of an automotive relay. This is the pin setup to the relay charger that I'm using. The pins on mine read 30, the flat pin is 30, the bottom pin is 86, the top pin is 85, the middle pin is 87A, and the outside pin is 87. And this is basically what it's going to look like. So 87 and 87A are your two switch points for your relay. Those are the two switch points. 85 and 86 are going to be the top and the bottom of the relay coil. Basically the magnetic, the copper wound coil that's used for energizing the electromagnet. And the flat pin 30 is sort of what I like to call the ground plate, because it's connected to the metal structure of the relay. It's also connected to the inside metal rod that the copper coil is wound around, and it is connected to the switch point here of the relay. And so basically what we're going to want to do in the circuit is we're going to want to connect the ground plate, which is 30, to the bottom of the relay coil. And that's going to turn basically the whole thing into one easy setup. Basically how it works is we're gonna take 85, we run that to our positive, to our driving battery, and then as the basically then this will be our positive, our 30 and our 86 are bridged together here. They are ran through a diode to the positive, our charging battery. Positive of our charging battery. The relay is a closed switch relay. That's the main importance of this relay, is that it has to have a closed switch here. And the closed switch is going to be, in this case it's 87A, and it's going to be ran to the negative of both of the batteries. So that's going to be basically like our common ground over here is our negative, which is our 87A. And that's going to be well, that works. So basically how the circuit works is our positive from our driving battery comes in and it will energize the magnetic coil and trip the relay, which is what the relay is designed for. But what happens is there's a magnetic field that is generated when the coil is energized with electricity and it's tripped. Then that magnetic field is, in this case it would be collapsed this way. The magnetic field is collapsed, and as the magnetic field collapses, the back EMF is what's going to be rectified and used to charge our positive of our charging battery. So in this case the relay is accessing what is called ambient or radiant energy, in the fact that we are accessing the back EMF, or the backflow of the electrons in this circuit. And that's what the design is on most over unity devices, is that you pick up the resonance or the back EMF of the circuit. So that's how it works. And quick little show of how it works here. Here's our automotive relay. We have it connected just like we had it. There's our two bridged, which is our white is going to be our out. Our 87A, which is our middle one, that's our black, so that's our negative. And then our top 85 is our red, which is our positive. And then here we have it going through a diode. This is just any regular diode that I found off any motherboard. I mean, as long as it's a high enough voltage. They say that the circuit, or I've tested this circuit and I've gotten it to charge volt capacitors up to 300 volts. So I recommend a diode that is, it doesn't have to be a huge diode, but not something super wick, because the circuit does put out some usable energy. Let's see. We're just going to use a 9-volt battery to run this relay, because it doesn't really matter I don't have a big car battery plugging in here, and the 9 volt works pretty good. So basically, I'm just going to show you here on a stack of capacitors. This is just a stack of capacitors that I put together. I put them all here in parallel so I can increase the amount of voltage that the capacitors hold. Each one of these is about a 250 volt polarized electrolytic capacitor, meaning that it has a positive and a negative. If I stack them together, the voltage is about 1,000 volts. So we should be able to test a good amount out of this circuit for that. And this will connect. So our driving, this is our ground from our driving battery. We're going to connect that to our capacitor being charged, and we're going to give that a so that's a ground. Positive. And capacitors are at 8.82 volts. So let's see what we can get them up to using just this 9 volt battery. Ooh, 13, 15, 17 overload. So that's as high as that'll take us. 27, 29, 30, 31, 33. We're just going up. We're going up and going up. I don't want to run the circuit too high, just because I keep having to discharge these capacitors over and over again, and it's not necessarily good for them to discharge that fast right away. But here there's a whoa. So that was our 35 volts that we got charged up to, and that was pretty quick off just a 9 volt battery. Now I've actually charged capacitors up to like 300 volts using 3 of these and a 12 volt battery. So there you can do some pretty amazing things with just these relays, and so the relay circuit is a very handy tool to get used to. I think that's it for relay.